So here, this is the continuation from the previous video, mensuration question part 2. So here, when the water tank is completely empty, the height of the water in the cylinder is 112 centimeter. Calculate the radius of the cylinder. In this case, both the volumes are going to be same. Volume of the water tank will be equal to the volume of this particular cylinder. Now we'll write here volume of water tank, which is a cuboid, is equal to volume of cylinder. I can see that the height is given in centimeter. So volume of the tank, I will write it in centimeter cube. If you remember, our volume of the tank was 495,000 centimeter cube. Now volume of a cylinder, we know the formula, it is pi r square h. We need to find out the radius. The height is already given there. So 495,000 is equals to pi r square into 112. This pi and 112, multiplication of pi and 112 goes to the left hand side. It becomes 495,000 divided by pi into 112 is equal to r square. So when we put this in calculator, 495,000 divided by pi and 12, we'll get the answer as, so pi and 112, sorry. Pi and 112, we'll get the answer as 1406. So r square will be 1406.8. So r will be square root of 1406.8. So when you find out the square root, you will get the answer as 37.5. We'll get the answer as 37.5 centimeter will be the radius. So we are done with the second part. Here what we did was just equating the volume of tank with the volume of cylinder. Moving on to the next part of this. So here in this we need to find out the value of x. You can see this is the x value here. A rod of length 145 centimeters. So this rod length is 145 centimeters is placed inside the water tank. One end of the rod is in the bottom corner of the tank. You can see here. The other end of the rod is x centimeter below the top corner of the tank as shown. Calculate the value of x. So here what we need to do is we need to identify in 3D trigonometry. What we need to do is we need to identify the right angle triangle that we are going to consider, and then you use Sokatova or Pythagoras theorem there. So here, in order to find out this side length, the right angle triangle that we are going to consider, just going to mention it as, I'm just going to mention this as ABC. So A, B, C. I'm going to draw that right angle triangle here. Now the hypotenuse is given as 145, A, B, C. Now the base AC, we don't know the base AC. Let's take this as D here. This vertex, I'm taking it as D. In order to find out AC, I'm going to consider the right angle triangle ADC. I'm going to consider the right angle triangle ADC. Here AD is 120 and DC is 55. So you use Pythagoras theorem. So 120 square plus 55 square, when you take the square root of it, you will get it as 132. You will get this side length as 132. That means AC is 132. This AC is 132 centimeter, or this AC is 132 centimeter. Now, considering this right angle triangle ABC, I have hypotenuse 142. I have the base 132. I can find out BC using Pythagoras theorem. So BC square is equal to 145 square minus 132 square. So 145 square minus 132 square, I'll get it as 3600. So to find BC, I have to take square root of 3600, which will give me 60 centimeter. So this length BC from here till here, this is 60. So x will be 75 minus 60, that is equals to 15 centimeter. I repeat, whenever we have 3D trigonometry, this is a 3D trigonometry question. The only thing is you need to identify from the diagram which right angle triangle you have to consider in order to solve the question. Take the right angle triangle, draw it separately, use your normal SOHCAHTOA or Pythagoras theorem. No other theory part we are studying here. So I hope you have understood this. If you have any doubt, write it in the comment box. Thank you for watching.